Electrolytic cells, unlike galvanic cells, they turn electrical energy or electricity into chemical energy. This also means the process isn't spontaneous, so it doesn't happen automatically. An example of this are rechargeable lead acid batteries. Obviously, you need to add electric energy into the dead battery, and then it's going to turn into some stored chemical potential energy so that eventually it can be used for another vehicle later on. In this Danielle cell, if you don't know much about Danielle cells, please look at the video link in the description where we go into detail about this. We had Zn over here being oxidized. It releases 2 electrons, goes through the voltmeter, and then goes on to the electrode for the copper. Now, electrolytic cells do the opposite. Instead of a voltmeter, you add some sort of battery or external power, and then it's going to make sure that it does the reverse. Okay, so any electrons, so let's say Cu2 plus over here, it releases those 2 electrons and it goes into the zinc. Okay, so it just does the opposite. This would mean that this reaction would then go backwards. Okay, same as this reaction would then go backwards, and then these 2 electrons would then have to go away, that as indicated there. That means this Cu2 plus also has to go away. Where is that? Okay, well, there's Cu over here, so then this Cu2 plus is going to go into the aqueous solution now. Okay, that's how it's going to go away. So then how about this part over here? Well, 2 electrons are coming in. Where is it? That's this one over here. It's coming in onto the electrode there. How about the Zn2 plus? Where is the Zn2 plus coming in? It's this Zn2 plus in this aqueous solution. It's going to now jump onto this electrode over there, okay? And then it's going to form Zns, which is this electrode here. And if there's a salt bridge like KCl, obviously the negative portion of this Cl minus, where's that going to go? It's going to go in towards here and then into the aqueous solution in order to neutralize any positive charges that are in excess into this aqueous solution, okay? Because obviously we have a lot of Cu2 pluses and this Cu2 pluses in that solution. Same thing for the K plus. This K plus, the positive is going to go in and neutralize any excess negatives because obviously that 2 plus went into this electrode. So electrolysis needs to be in molten state. So we need the solid to turn them into liquid. How does this occur? You just have to use extremely high heat, okay? You can't dissolve it in water. So we have liquid turning to liquid and liquid, okay? And then you just have to balance it, so you put a 2 in front of that Br minus, and then you're just going to split them off into half reactions, okay? So let's do the lithium ones together, okay? So obviously 1 electron needs to be put on the reactant side in order to balance that neutrality, and then we'll do the Br and Br over here. We're going to be putting 2 electrons over here to balance the neutrality as well, because there's a 2 Br in front of there for the ion. In order to cancel out the electrons, you got to times 2 for this whole thing over here. Kind of what we did down here. Now we can cancel out this 2 electron. We can cancel out this 2 electron. What we're left with is this one over here. Now normally this one here is the cathode, and normally this one here is the anode. But because this is electrolysis and it flips, the cathode then has to become negative, alright? And the anode, normally it's negative. This one has to become positive now. Try these questions on your own. I'll be giving you the answer shortly. These are the answers.